Torching 101 at Factory Farm. So, a few main things. Okay, we'll cover basically just the whole setup, not just the fact that you can pick up a torch and turn on the gas and use it, but what else all around it. Things like cleaning.
Safety.
So cleaning, safety, things like that. So here's the equipment. You've got your acetylene bottles. What's wrong with that right there? That has to be a stable system. Just starting about safety. Can anyone see what's wrong with this? Any problems? Yeah, okay, so we want to have these that if someone knocks this over, you don't knock it over. So it should be tied up. Make sure this is tied up. And I don't know about these straps. Are they going to work? Or we might probably need better chains, but that definitely has to be tied down. Oh, that's loose. So there's a violation right here. So we need to fix that, but for now, for this lesson, we'll keep going like this. Gas. Okay, so you've got oxygen and acetylene. This is oxyacetylene cutting. That's the industry standard for just about all the cutting that you can do. There's also oxyhydrogen cutting, oxypropane. Propane is less hot. Oxyhydrogen is super clean cuts, but it's harder to get them started. This is oxyacetylene. So we'll start from how do you turn the system on? Safety. We'll kind of mix all the topics together. How do you turn it on? So turn it on slowly. That's the oxygen. Until you see that the arrow goes up slowly. This is actually, let's look at this. Right now, I closed it off and it's at pressure still. The official recommendation is you should bleed that all out. Open up the oxygen. That should bleed out. Opening up the oxygen valve on this. On the torch, that's the acetylene valve, oxygen valve. Open it up, bleed it out. In principle, you're supposed to let that bleed. Okay. We've turned it on. So we turn it on slowly, and then turn it up all the way. Whoa, that arrow didn't go up. What happened there? So that means there's actually a regulator here. After you turn this on, if nothing went up here like this, the low pressure valve here that shows like between 0 and 100, that didn't go up. Well, this is the thing that actually turns it on. If it's loose right now, that means it's off.
The low pressure gauge is broken.
Oh, not on this one. It's broken on the other one. So here, turn it on. Once I see some pressure, see it starts going up. How much pressure do you want? Let's say the 1/2 inch is a typical cutting width. Typically keep it on like 25, 35. The official word on 1/2 inch cutting is that you go up to about 30. And as far as, let's move on to the acetylene. Once again, let's bleed. Okay, that valve is broken. Does that fail the operation? No, because you can actually, if you understand what you're doing, you can set it properly. So I'll tell you how. You want the flame to be such that, I'll turn it on right now for you. Let's look at the flame. So we've got the oxygen turned on right now. That's the oxygen. This green hose is oxygen. This is acetylene. We're working with what's the proper pressure for acetylene. Okay, nothing is coming out. I'm going to turn it up. See, that's all loose. That's loose. There's nothing there. You can tell that. If you're like, okay, that didn't light. What's going on? Is my striker broken? Well, no, it's lighting. Nothing's happening. Is this open? Oh, no, it's closed. Let's open it. Anything yet? No. So turn it up a little bit. Okay, I saw that this other valve went down after I opened this up a little bit, so that means it sent some gas in here. No gas still, but this is open here. Well, I'll close it. The main valve, the high pressure gauge, went down. That means there was just residual gas. It's not continuing the gas. That indicates that I actually didn't open that yet. So let's open it. Slowly. Okay, no pressure is not going up. There it goes. So that goes up to, there's like 300, 250 psi in there. The main valve went up. So we've got pressure here. We don't know about the micro regulation here with the regulator, so I know there's a little bit. I turned it up a little bit. Let's see, do we have anything? Okay, we've got a little flame. It's not a lot. Let's turn it up a little bit. So I don't have a gauge there, but I can actually set it properly. I want it to the point where you get this feathering, you have the black smoke start to disappear. So let's turn it up. I'd say like that. That's pretty, that to me is, you hear the whizzing. I mean, there is black smoke still. Well, let's look at the limit. How far can you go? That's as far as it goes right now. That's as much as we have. That's a full flow right now. I'm going to turn it down a little bit. I think about there. That's pretty decent. Well, let's try this again. It's important to know like what the proper flow is, so even if you don't have valves working, you can actually do that, because we're a factory farm and nothing works. Oh, okay. So you see that was much stronger. That means I didn't open up this valve enough to make it go all the way. So let me shut this down a little more and start from scratch again. Make sure the main valve here is open all the way. So let's see this. Whoa, that's a lot. That's way too high. So I was messing with you before. I was in the full flow. I didn't even know that was not open all the way, but okay. That's open all the way now. Let's see what is it at max. You can go pretty far. That's way high. This is perhaps as much as I need for like ½ inch. I know this from experience. If you go like all the way, it balls out, like really far out. That kind of level will get you to like 1 inch and above. When it's really wild like that, just really wide, you can't see any smoke. So that's how you know.
If you have it too high, can you do a cut?
Sure you can.
Put a balloon just welding back together.
Way too much acetylene. Yeah, so what happens, how does this work? The acetylene just heats things up. What actually cuts it is the fact that you have the oxygen lamps. That's what does the cutting. So if you have a lot of acetylene going, you may not get the flame to be proper. So I'll discuss how you get the flame.
Too much of an area being heated.
Could be. Your weight mostly,
push it away.
not really as much as moving back in, but you're just wasting gas. That's pretty much the main thing. Like conservation, resource conservation, don't waste gas. So what I'll do then is, for setting this, what I'll do is, with this throttle all the way open, I will adjust this valve to get to that wild flame, which is like the farthest you ever want to go. And as soon as you hit wildness, you still can keep cranking it. Don't, just stop there. So let's see where that takes us. Are you ready? So open all the way. So this is really about understanding the flow, like how much flow you need. So I'm open all the way. So I'm going to just do this too. Okay, that's perhaps as much as I'll ever need. That will get you to 1 or 2 or 3 inches. That's fine. So I know that that's pretty much adjusted. So now I will select the amount of flame that I really want for cutting. Like, let's start with very thin metal, like 1/8 inch. So by feeling, I mean that's what you need to do with the flame, is to get the substance, the material hot enough that it basically lights up to red, and then you can start cutting with the oxygen. So let's talk about the oxygen now. So let's say we have this low flame like right now. That's not a lot, but this will be enough for like 1/8. And let's start with 1/8. So turn on the oxygen. To do that, turn on oxygen all the way here. And I need my glasses. Does somebody have some glasses? Right here. I'll use these. Okay. So once again with that gas, very little. Well, I mean I can turn this up, this way up, but keep it low. I mean, maybe like that much. So now the second valve here is oxygen. Let that go all the way. this valve right here is what actually allows the oxygen to flow through. You want to set it down so that you get the white flame, this feather, the white feather, go all the way down. You see that feather? Make it retract all the way to the very tip, so that you only see those tiny feathers. That's how far you set it. And that part right there, about an 1/8 inch, is the hottest part of the flame. So let's cut. Okay, sorry. Prior to cutting, what are some considerations there? Did someone cut this? Or like, if I take this, what I want to do to this before cutting? This is an old piece of metal, kind of junky.
Clean it a little bit.
It's a good idea to clean it. Yeah, I would go like wherever I'm going to cut it. Quick way is, I mean, you could use wire brush, but grinder is much easier. I mean, I would just like, okay, so there's this slab from the last cut. Basically, any slab dirt insulates the metal, prevents you from heating it up. Okay, so I'll just clean it up real quick.
Safety violation, bro. That's a safety violation. You gotta warn people in proximity who are not wearing ear protection before grinding.
Ear protection is a good point. I should be wearing earplugs.
And warning other people too.
About earplugs. Good call, Yunso. And I knew I was going to spray you, but you got your glasses on and you're out of the way enough. So this gets down to the metal. You're going to be able to heat that up really quickly. So let's just do what an 1/8 inch cut. So let's talk about some considerations. Two things before we cut. If your torch tip, two things. This is going to have flames coming off it, so you got to make sure you've got flammables out of the way. Any flammables on here? No gasoline, absolutely. Oil will light up, so you want to remove oil. This is water. Gasoline, if you have a gas container somewhere, you're asking for an explosion. Okay, if I'm going to cut here, can I cut it right now? Yeah, I got to move all this stuff. It's all plastic. We're going to get all spatter on it. So let's either move this out of the way. Let's do that right now. So stuff like that. Any plastic, get it out of the way because you're going to get spatter all over the place. I think I'm done with the grinders, or maybe later, but so that's one. What else? Position of the hose. Don't have this like laying where you've got all this in the spatter because you got flames coming down there. You're going to burn your hose. So don't do that. That's the main thing. Regarding a torch, you can also visually inspect, like we saw that the feather, nice little flame was regular, symmetric. That's how you know it's a flat flame. If it's non-symmetric or there's like pops or noises, that means your tip is dirty. How do you clean it? Aaron, how do you clean a tip?
Wire cleaners.
So here is a broken version of these wire cleaners. Basically what you do is you have to open up the torch. You can try poking in from that side, but you're going to poke dirt inside the torch. So you take it off. You take off the tip. So everything is closed off here. I should have that closed too, but that's fine. Okay, so here's the tip. Take it from behind, take it from the back side, and you stick in your needles, okay, the little needles, your cleaning needles, stick them in from behind the holes, and they should poke all the way through.
Are all tips the same?
Tips are not the same. There's a size of a tip for every thickness, so that's another good point. We've got different tips here. From the finest, they're graded from like 0, 0 to like 7 or something. But tip number 0 is 1/4 inch and under. Tip number 1 is about 1/2 inch. Tip number 2 and 3 is like 1 inch and up. So this I look on the side. You look at it on the side. It says 2-3-101. I'll take probably it's the first number. So number 2 tip. The hole. Can you look at the hole size? The hole size is maybe like 1/16 of an inch, and you'll see a big difference between a tip like this, which is much smaller. That I believe is that's a 0 tip. So I'll use this for quarter and under. That's a zero tip, tiny hole, maybe like a 32nd or under. I'll use this one for this very thin stuff. Now don't do what Aaron did yesterday, which was don't take a grinder and try to grind the dirt off of this. You just destroy the tip. These are precision holes and they have very fine regulated flow. You don't take a grinder or a surface grinder or any kind of thing to this, you destroy that. It's no longer any good. These are, what is it, brass? Is it copper? If it's copper, it's for good heat dissipation. I don't really know actually. Copper or brass. This is brass. This is a brass handle. That looks like copper. It's kind of darker. Okay, so I'm going to use a number 0 tip.
Is that discoloration? Is that a problem?
Which discoloration?
The black.
The black?
Yeah.
That's not a problem. That's cosmetic. Unless you have good questions. That's cosmetic. Okay, so is the gas back on there? Okay, so I'll light this back up and show how that goes. Turn it down.
Use any clamps on your metal, or is it okay to
Right now it's going to fall down, so safety. Steel-toed boots. If you have a thick piece of metal that you're cutting, the thing is going to drop off when you finish the cut. It's going to fall down. Steel-toed boots, and besides, just be in a way where the stuff is not landing on the feet. Okay, so I'm going to start.
Are there any considerations to the way you should stand?
Stand in a very comfortable position. Maybe lean down so you have this thing where you can get your hand on something. This is just freehand torching. There's not precise, just kind of rough cuts. We'll show you how to do more precision cuts with a ruler like that piece over there. Okay, so I'll start this and I'll give you a little quiz. So, yeah, let it feather out a little bit. That's like this is all laminar. This is like a little turbulent. That's how much you want. That's plenty. Plenty right there. So make that feather tip disappear. Whoa, that's long. That's better. A little bit of that noise there. See, that's a little too long.
What's that noise?
You want a little stuckage in a little dirt or something, a little popping. You want to hear a little bit of that noise like that. You hear there's a little bit of noise there, kind of like that. That's dirt in there. We might keep doing that. Okay, in my position right now, can I start cutting? Why not?
Wire.
Okay, look for that stuff like that. That's down there. You can burn it. You can cause an explosion later. So get it out of the way. And now let's start. Okay, that was already stuck. Okay, so that's how it should look. Get yourself in a comfortable position. 0 tip. You see pretty much immediately that just turned red.
How much are you squeezing the handle right now?
Push it down all the way. If you miss it, if you stop cutting, then go back and restart again. Okay, that's a 0 tip. There's even double 0 tips, even finer than this. For that was overkill. What I saw right there, instead of getting a pretty nice clean edge cut, there's all these bubbles. It just basically melted right away. That's even too much. So that's even too big. So this kind of tip could probably get you a 1/4 inch very nicely. Let's see that. So this is let's do a tube, and I'll demonstrate what happens when you don't clean it off first. This is painted, so it's going to take a little longer to cut. But is it going to be bad? No. I mean, the paint is going to pretty much blow right off with the heat. So we'll do that. I'll show how you do a little hole.
Any safety considerations?
Yeah. If you do that, don't point it like that because you'll get all the sparks at you.
With
Watch
the
your
paint,
feet.
anything on the surface of the steel?
Yes. Don't breathe it. So you want to be in an open air environment or have a fan behind you. So this is going to be paint vaporizing. You don't want to be breathing that. So don't put your nose into it and sniff it all up. Stay away from it maybe. And we're in pretty much an open air workshop. So let's see how that looks. And this should,
When you heat that, the heat kind of like just blows out the side of that tube, right?
yeah, you're gonna have sparks. I mean, there's like 30 psi of pressure. That's like a mountain bike tire.
Okay. So if you're just standing like a foot away from the end of that tube, you're going to feel really hot.
Well, you're gonna get all sparks burning your shirt. And what's wrong with my clothing? Is there anything wrong with my clothing?
Cotton.
Huh?
Cotton.
Yeah, it's flammable. I mean, right now, what you'll see is that you get a bunch of little burn holes from welding more, but here, you know, you can start feeling really warm. It's like, oh, there's a flame on my pant leg or something. So this is not optimal for cutting. You should wear leather, protective leather wear. Okay, so let's try it. So once again, go to the turbulent flow, open up the oxygen all the way, and get it to so that's the wide, make that disappear, and further than that, make it shrink and get loud at you, like a little loud. Yep, so this is good. So you'll see that stuff is going to be coming either way, out one way and the other. So I see it, you see it basically start getting red hot. So the paint is like right there now, the paint's pretty much burnt off. Well,
Are
I
you going to
started.
cut through the whole piece?
Huh?
Are you going to cut through the whole piece?
No, I'm going to poke a hole through it. So you see right now it's got red hot, and you know when, I'll tell you a fine point, you know when you're ready when, upon examining, you can actually see the star pattern of the holes on the metal itself. You've got 6 acetylene little holes, 1 oxygen hole in the middle. You know definitely that this metal is hot enough. We're piercing here. So you're not coming from the edge, you're piercing it. That means you're going to get a little crater of spatter. You want to make sure that you blow right through it so it starts going the other way rather than in your face. So you know that you've definitely got enough heat on it. Look at that detail there. You can see that pattern of like a few holes actually by the gas pressure, by the very gas pressure, you get a little indentation. Sometimes you can see like the exact hole pattern here imprinted on the metal without you starting to cut it yet. That's how you know that you absolutely got it hot enough. That's very important for things like if you're going to pierce through, for example, 1/2 inch. If you don't pierce right through it, if you're not hot enough, you're just going to get this whole mess, crater. It's going to spatter all over the place. And then after that, because it's all messed up, the way the gas flows, it's going to be very hard to poke through that again. It makes it much harder. So make sure you have enough heat up front to make it go through all the way. About piercing, 1/4 inch is easy. 1/2 inch is about the limit of what you can pierce without going to the edge. What I mean by pierce, I'll get back to this hole here, but pierce means that you're not starting at the edge where it's easy on the edge because the whole edge gets hot, you can see it. If you mess up, you're not blowing a crater on your face, it's going the other way because it's the edge. But for me, like with a 2 or 3 inch tip, it's fine to do pierce on about 1/2. That's the practical limits for factory farm standards. Above that, you have to pre-drill a little hole and allow that hole to get really hot and the gas, and then if you don't start cutting, you're not spraying all that and making a mess, it's going through that little hole. So do a little pre-drill hole like an 1/8 inch, 1/4 inch hole if you go through thicker than 1/2 inch. Okay, so here let's just show this piercing, just how it looks, what it's like. I'll do a circle, and you'll see the speed at which you can cut pretty much right like butter once you get it hot. Okay, so there, you got the turbulent flow, you got the oxygen all the way. Get the feather down get it down to the fine point. Make it a little noisy. That's dirty tip. There's some dirt in there. We need new tip cleaners. Okay, so I got red hot. Nope. Now it's good. Yeah, so that's an example of a hole. So 1/4 inch. So I thought I had it already. It was pretty hot on the surface, but this is actually a 0 tip. So that's about the limit of what you can do with a tip like that for piercing. Okay, let's go to a fatter tip. I'll go through. Let's pierce a hole in 1/2 inch. Can I do this one or? What's to be shown about piercing a hole through 1/2 inch? You understand this part about when you visually look at it when you're piercing. I won't do the 1/2 inch. We'll go straight to like this stuff here with a fat tip because we're taking a lot of time here. Make sure that you see that imprint on the metal itself from the hot flames going into it and actually poking, because the metal gets literally molten and you see the in fact, I'll show you what happens if I never do press so I'll use this right now. I'll show you what happens when you never press the cutting gas. You should basically, if you get this to the point of heat enough that you want to pierce, like if you keep going at it, you'll just keep like making like a little crater in there. But you probably won't poke through the whole thing. I'll show you that because that's interesting to see. Okay, so there. So I'm gonna just heat it up, keep heating it till okay, that's getting red hot. It's getting to the point that material is actually flowing out of that hole. And I'm literally just moving that material out of the way with the pressure of the gas, which is the acetylene, which is only like about 5 to 10 psi here. So I want you all to look at that, see what happens there. Yeah, I just kind of like got it all bubbled up. Huh? Say it again?
You gotta wait for the paint vapors to die down.
Yeah. I basically created a bunch of craters. Yeah, there's like a bit of slag on top. It actually poked a little bit of a hole in there. There's just a little bit of slag, partially oxidized iron, and it did poke a little bit in, but we never cut through. But you know, at that point, I mean, that was way, way hot. If you hit the oxygen, it would have went through. Okay, what else? I got my little notebook of items to. We talked about tips. We talked about pressure, starting, cleaning. So don't put a grinder to that. Each tip is about $20. I'll go over shut off. When you shut it off, just turn both of these off. The proper procedure is after you turn them off completely, you should also bleed the lines here. That bled the oxygen, that bled the acetylene, so that, you know, safety, you don't have the gases in there. I'm not sure how important that is, but so that's proper shut off.
Cutting a straight line in a circle.
Say again?
Cutting a straight line.
Cutting a straight line.
Circle. Yeah, then we have the circle.
Do we? I have not seen that. Can you show me that?
It's in the box and it's everywhere.
Okay. That'll be lesson 2.
Okay. Yeah.
So through material, yeah. One point about safety: have some extinguishers nearby in the workshop right now. So you've got them by each of the main. That one close to where you're torching, but I know there's one on every one of the middle. I just moved them, but I think it's a good idea to have them clearly accessible under the main poles, and then there's one across the other side. Fire safety. Other applications. Okay, I talked about clothing, eyewear, so you got to have your shades. I also like Yunso's riot gear. Why would you want this? Typically, I mean, right now, you know, unless your face is in there, you're pretty good to go. But you can also torch upside down. If you're going to torch upside down, I mean, I can get under this table right now, or I'll show you that. I'll show you what happens upside down. That's like more advanced stuff, but I think it's worth showing because there's going to be cases where you want to do that. I mean, you just don't have any other means. So even if you're not going to do this, be aware that you can do this. And a face shield like this is really good. Like I used a welding mask to do that, and it works relatively well. The only problem for me is going to be that I'm going to get spattered all over here. So yeah, you want to don't have things. You can very easily get stuff under, so you get little burns. That's not good. So do that.
Put up my collar here.
Uh-huh.
Make like leather jackets.
Leather jacket would be good, but I mean this happens sometimes. We've done upside down torching, like in the field experience with a tractor. So let's just show that what that would look like. So let's turn that back on. This is getting too extreme. Okay. Once again. And this is going to be easy here, but I'll spray like over there, so I'm going to spray on you. But this upside down, it's like, if I don't have to be under this like that, it's pretty fine. I mean, you can just go, it's going to go that way. I mean, face shield is nice here if you're like looking underneath it. But this is certainly doable. Off the edge of a table, you can poke a hole that goes, say, and point it away from you. Like, if you point it straight up, you're going to get craters all over and they're going to fall on you. So if you want to just make a little hole, just point it a little that way, and it looks like you'll probably be fine. So try to get as comfortable as you can in a very uncomfortable position. So that's an example. You see that spatter goes on you. Like here, it went on my knee, so it gets hot. So leather pants would be totally fine with that. But okay, so that's from underneath, and that's not fun.
I got burned like that.
Yeah. But it's certainly useful in certain places to do it. You can't avoid it. Okay, what else? So on my list of items to show. So that's a demonstration of the face shield upside down. We did the 1/8 inch, so we'll end up with a very thick piece, so I'll show you how to do that. We talked about cleaning. So I'll just show, like, as far as other applications of torching, well, I'm not going to show too much else, but a torch like this can be used to weld as well. You use a different tip, but you basically heat up the metal and you fuse in something like a welding rod in there, and you actually, by heating the metal, you can bond two pieces together. Now, of course, it's much better to do it on a MIG welder, but you can use this for welding. You can also use it for heating things. You can have a rosebud that, you say you have like this very, very wide tip that makes a wide flame that you can heat up something. Say there's a shaft seized up. You heat it up and it will come right out. So that's very useful. Another application would be flame hardening. Let's do that. So little example of flame hardening. Where you can let's take an object that we want to flame harden. Let's take a nut of some sort. Let's take this nut. Basically, if you heat this up to red hot and then you throw it into oil or water, this, by quenching so fast, it changes its crystalline structure and becomes very hard. So we can actually use that for things like on a plow, you can make a tip harden. On the trencher, we can flame harden the tips, and that's actually what we're planning to do. Water hardening, oil hardening, they have, say again? Could do that. The only problem is you're going to deform things. With high heat, you're going to be tending to deform things. Like a nut like that is pretty solid, but you can't really flame harden something without it warping a little bit, and so it's not for super precise things. You know, and like, has anyone heard of like O2 steel? That's like oil hardened. That's heated up and then quenched in oil. So let's see what happens with that. So I'll get this red hot, and I'll throw this into, see, but how can we tell, what's the way to measure the hardness of it? I don't know, like, do we have a scribe?
Yes, it is.
Can you bring out the scribe? Let's take this, let's scribe it right now, and see if we can still scribe it after we flame harden it with the water cooling. So that's one application. Okay. So can I scribe that? I'm going to put an M on that. Yeah, okay, so that's like moderate pressure. I put an M on it. I'll just see for fun if I can do the same afterwards. I've never done this. Yeah. Okay, so let's see what happens. Just put that on there.
Call it Andy.
Yeah. That's still the small tip, so I'll take a little. I mean, I'll add some more heat to it. This is where a rosebud would be handy. It's a wider flame. Now I got to kind of keep going around it. A rosebud would get it all heated up more. And this is a small, very small tip, so it'll take a little to harden. But you see it's starting to get red hot on top. You can see that definitely. It's getting red. It's nice and red. Nice and red. Okay. Yeah, the water now, it's like 100 degrees or so. It's hot enough that it's, so there's a lot of heat in that little nut. Okay, so let's see how the scribe works now. Let's see my M. Okay, I see that M. Let's see, where is that? Yeah, there's that M on this side here. Thank you. See that? Let's see. I don't know. Is this gonna scribe still? This might. Whoa. Definitely different. Definitely different. Yeah. I mean, I could feel that before when I was going at it. It was like I can, like, kind of continuously go. Now I see that. I don't know.
Will the thread still work?
I don't know. I definitely felt a qualitative difference in hardness. How do we quantify this? What's the real test, like durometer testing? I don't know what that is, but
Constant pressure with a constant tip.
Constant pressure with a constant tip, and then you see how deep that goes. Okay, we'll do that as soon as we. Yeah, thread should. Now, did this get deformed? No, it's still pretty good. So that's now a hardened nut. Yeah. Great. Yeah, I think it does work, at least qualitatively.
When you say hardened, what do you mean?
Hardened means it's going to be, you can't, if you put pressure on it, like with a big hydraulic cylinder, you're not going to deform it as easy. Like it might take you, instead of 50,000 pounds, say you press 50,000 with your finger, you're not going to deform it before, and now after this, with 100,000, you're not going to deform it. Before 100,000 would have just squeezed it and maybe flattened it a little bit. So it's just harder. Pounds per square inch pressure resistance. Okay, so it makes it more brittle. So it's harder, but at the same time, it makes it more brittle. So that's good for things like abrasion resistance, but it's not good for like if you whack it hard with something, it might actually shatter. So that's another point. Once you torch stuff, all of those cuts, because they're just air hardening, makes it much harder. So for example, you're not allowed to, like after you make a torch cut, you're not allowed to put that torch cut on a bandsaw, on an iron worker, on any machine that's got a metal blade, because this is harder and it's going to destroy your blade. So today I caught Aiden trying to cut a piece of metal that had some welds on it. That also heats up the metal. You don't want to go through that with any tooling, because it's going to destroy your tooling. Okay, so last thing, thick materials. So with a bigger tip, you should go through metal like this. That's what, 1.5 inches? And I'm not going to pierce through it. Like if you try to, it's going to be very, very hard to try to go with a hole through it. It's literally impossible. So but you can start pretty well on the edge. So let's just give that a little try and see what it looks like to cut a chunky piece. So I'm going to need a big tip. So let's get a 3, which is good for about 1 inch or 2 inches. Well, unfortunately, that's the one the iron ground down. So this is what happens when you grind it down. Okay, no 3s. What is the biggest we got? We get 2. We'll try that.
Can't look through your glasses.
Can you see anything?
It's down 2. Okay, that's a 2. That's going to work. The hole there is pretty big. Off the edge, you can probably not too bad to do that. Make sure that's all. Okay. Okay, so and I'll comment on when do you know that you've got a good cut. The good cut is when there's a constant flow, like a nice stream of molten metal coming down from the bottom. That's how you know. If it's like going all over the place, like left and right and whatever, that means you're not getting the proper heating to allow the oxygen lands to basically push it straight down and out. And you of course know that if it's spattering back at you, you didn't go through all the way, you have to back out a little bit, and so forth. Okay, so let's try this. Okay, let's turn on the gases here. Okay. So I'm going to need as much flame as I can get. That's good. So get it away from the white to the tip. Not that much. Get everything out of the way here. Maybe get that suppressor out of the way a little more. Yeah. Okay. Get comfortable with clothes. Touch the tip on the metal, you blow it out. So don't touch the tip on the metal. So I'm looking for the red hot to happen. I see it pretty red hot right on the edge. Get a little more down. I want to get it so that the edge is basically like melting off. You see the little bit of spark coming, that means you're actually shaking bits of metal off. It's ready to cut. Oh yeah. that's not easy. You have to be, this is where a mechanized torch system that's very steady, because you see it was kind of going all over the place, and it's very slow, but that's the extremes of what we'll be doing around here. So pretty much, yeah, I mean, that's probably, no. Yeah, okay, there it is. But see, that's, I mean, that's not so pretty. If you had it on a CNC torch, that would be a nice line. In fact, what does a CNC torch give you? That kind of a surface. This is CNC torch cut. So that's as good as it gets. And you see the lines, those kinds of lines indicate that's oxyacetylene torch. Those lines correspond to the actual flow of oxygen moving through that. And the farther it gets into the metal, like it starts to bend a little bit, that means it's like almost not going all the way through. But that's mine. That's automated. Yeah. Okay, so that about wraps it up for.
Can you tell us a bit about the
torching
chemical reaction
101.
of the torching?
The what?
The reaction that occurs chemically.
The chemical reaction?
Yeah.
I don't know much about it. All I know is that you've got iron, and then you've got high temperature plus oxygen, iron oxide that melts out, just a molten slag that pushes out the other side.
Exothermic reaction producing energy, right?
Exothermic reaction, so basically, like, imagine you light a piece of paper on fire. This is what you're doing here. You're actually lighting the metal on fire and blowing it through. That's what's happening here. Exothermic as in extreme, and maybe I should show you that. Turn off the actual acetylene, and you should still be able to cut. Let's try that. That's a good point to try.
Because
For
the
that,
energy
you need some
generated by the
pretty clean metal.
exothermic reaction continues to provide the thermal energy required to heat the metal up.
Yes. The actual burn, the exothermic nature of the reaction generates the heat, the flame, that as long as that oxygen keeps feeding in there, the reaction is sustained. Let's see how that works. I've actually never really tried that. That should work. So that's a nice low flame. So someone want to just turn it off after I start cutting. Aiden, why don't you just turn it off? Okay, you want to turn it off? No. There's no acetylene right now. Yeah, so it kind of went on for a little bit more after the acetylene went out. Definitely need a little bit of acetylene. But the point is that, like that big flame that you need to start it, that's good to start it. But after that, if you had like a third hand, it's actually a good idea to reduce the acetylene because you're just wasting gas. You don't need it. And actually, you can do that on a torch table. You can minimize the flow of the. After you get the pierce or cut started, you actually want to minimize the flow of acetylene to minimize your gas use. So that's what automation can get you, really, really efficient gas use on torching. So thank you very much. Okay.
Thank you.
Any other questions? Cutting a string line. Oh, cutting a string line. Forgot about that one. But on that, like if you have some long, you want to get a nice straight cut. I mean, you only have so much precision by hand. So what you want to do is, if you want to cut a nice clean line, you do your cutting along a form that's going to be guaranteed to be quite straight. So as long as you just touch it, keep touching on the side of that. So you start the cut, you keep going. Just as long as you keep your tip, don't migrate off of that. You cannot go but go straight. So that's nice. I prefer using like 1/2 inch because it's really nice. You can just latch that on like that and do a very straight cut. So you can get pretty nice manual cuts just with a ruler, so-called ruler. Yeah. Anything else? Thanks.